Let us move on with the SQL injection from Junior Penetration Tester learning path. So this is the final in the introduction to web hacking, the final room. We've completed the first 3 tasks in the previous video. I believe I need to start a machine or something. Let's see, maybe if we get to this point in the video, it is useful that we start the machine and the attack box beforehand. So, what is SQL injection? We've seen what is SQL, structured query language. SQL injection is the point wherein the web application can turn, using SQL, can turn into SQL injection when the user provided data gets included in the SQL query. So, it's probably not the best. SQL injection is, simply put, in pen tester terms, a way to exploit an application using the SQL language. What does it look like? Take the following scenario where you've come across an online blog and each blog entry has a unique number ID, such as ID 1 up to 500. The blog entries may be either set to public or private depending on whether they read from public release. From the URL above, you can see that the blog entry been selected comes from the ID parameter in the query string. The web application does this to actually retrieve it. Select everything from blog where ID equals 1 and private equals 0, limit 1. So give me just one result. Not exactly. So select everything from blog very specifically where ID is 1 and this blog is not private, and give me exactly one result. From what you've learned, you should be able to work out that the SQL statement is looking in the blog for an article with the ID number 1 and the private column set to 0, which means to be able to be viewed by the public, and results the limits to only one match. Alright, let's pretend article ID 2 is locked as private, so it cannot be viewed on the website. We could now instead call the URL 2 semicolon hyphen hyphen. Is that the hyphen or minus minus? Which would then in turn produce the SQL statement, select everything from blog where ID equals 2. This is where you're actually injecting other characters in the query and private equals 0, and what the application is going to understand is that us by using the semicolon signifies the end of the SQL statement, alright? And then the 2 dashes cause everything afterwards to be treated as a comment. So we terminate this here, we terminate the query here, the statement here, and then everything that follows, I wonder why this is still connecting. Everything that follows signifies a comment. So what you're just running, in fact, is this thing, which will then return the article because it's going to ignore the private 0 and limit 1. So this was just one example of a SQL vulnerability of a type called Inband. So this one has failed to connect to the server. What do you actually do then? Terminate the machine? Interesting. What character signifies the end of a SQL statement? Semicolon. Inband SQLi. Inband SQL injection is the easiest type to detect and exploit. Inbenches refers to the same method of communication being used to exploit the vulnerability and also receive the results, for example, discovering SQL injection vulnerability on a website page and then being able to extract the database. Error-based SQL injection. This is most useful for easily obtaining information about the database structure. So this actually means that by causing an application to produce errors in the communication with its database, if the application is not configured appropriately from a security standpoint, the errors that you're going to get are going to reveal information about the database. So this often can be used to enumerate a whole database. Union-based SQL injection. We've learned what union is in the previous video. This type of injection utilizes the SQL union operator alongside a select statement to return additional results to the page. This is probably the most common way of extracting large amounts of data via SQL injection. So we've started a machine. Level 1 of the practice contains a mock browser and website featuring a blog. The key to discovering is to break the SQL code query. So what are we going to do here? We're going to try to break it like this. Do we click enter? So these are by using different character types, apostrophes or a quotation mark. So in this case, let's use an apostrophe, enter, and we've caused a SQL error. You have an error in your SQL syntax. Check the manual that corresponds using this. Try typing an apostrophe. As you'll see, this returns a SQL error. We can now exploit this vulnerability and use the error message to learn more about the database structure. So first, we'll do union select 1. The used select statement have a different number of columns than 1, 2. 1, 2, 3. Hi and welcome to the first article from my website. So in this situation, the article is being displayed because it takes the first return result. So it takes the first return result, and we have 3 columns here. To get around that, we need the first query to produce no results. So in this case, we're just going to replace 0. And then we can see the article is just made up of the union select return column values 1 to 3. We can start using these return values to retrieve more useful information. So we first need to get the database. 1, 2, and then we have 3, and we replace 3 with the database. We can see the name is SQLi1. Now, to actually generate the list of tables in this database, we have to do the union select 1, 2, and then what we need to replace here is group underscore concat table name. So we need the table name. We need to concatenate the table name group concat. So we'll have a group concatenation of the table names from information. So information underscore schema tables. We need the table names from information schema tables. The information schema is actually where the entire logistics of the application or the database actually is, where in this case we know the table. We want to get all the table names as a group concatenation from the information schema tables exactly where the table underscore schema equals SQLi underscore 1. Let's see. Articles and staff users. So we have the tables, article and staff users. Now, what do we need to get furthermore? We need to get, so we have the table names, and we're interested not in the article, but in the staff user. So we want to retrieve, as a penetration tester, to prove your point. It is often not the case to go that far, but for simplification or for exemplification purposes, we're going to keep on using the group concat to actually get the column name. So we need the column name from information schema columns, so not tables but columns, where in this case table name, not table schema, but in this case table name, so we're being very specific. Table name is staff underscore users. Let's see what we get. We get the ID, username, password. Now we have a sort of very rough I mean, not necessarily very rough, but quite specific idea of what the staff users tables look like. It has 3 columns: ID, username, and password. What we then want to do is to actually dump the information from here, from the staff users table. So what we're actually gonna do is concatenate. In this situation, we're gonna concatenate the username, then we're gonna add a semicolon, or colon, semicolon, right? Password, separator, so this is gonna be separated by a break, so it's gonna jump onto the next line. Notice that I have used quotes and they use apostrophes. I don't think this actually makes any difference, but let's try to be consistent here. So BR break, then we forget about everything and just tell the SQL query, tell the database actually via SQL to get us the information exactly from staff users. And notice that we don't need to put the table name in any sort of quotation because we're referencing it directly. So let's actually run this. We have the username and the password. So the flag, again, we use the group concat method to return all of the rows into one string and to make it easier to read. That's why we added a breaking point. So we added the semicolon to the colon to split the username and password from each other. Instead of being separated by a comma, we've chosen the HTML, so we could just say, in this case, separator, comma, and you can see that all of them are there. Or instead of using that, let's actually try and see if it works with double quotes and then a hyphen. Of course it works. So we have the username, password. For consistency purposes, the separator, we're going to put the separator into quotes, double quotes, and then the separator is going to be an HTML separator break. Better. What is the flag after completing level 1? What's the flag here? How do you get the flag? You should now have access to Martin's password to move to the next level. So what's Martin password? PAS $$ word. So username Martin and then $$ word. No results found. Oh right, it's under my glasses, under my nose. So let's actually type that in: THM SQL injection. Again, this is not my strong point. I don't actually look for SQL issues in my penetration tests other than the very generic ones. So I'm actually doing, in my penetration tests, I'm actually doing the very generic SQL tests to actually make sure that the applications have good level of protection. And if they have a good level of protection, I just don't go further as someone in a bug bounty scenario would try to go. If the application is secure from all standpoints at a very broad level, that is often more than enough when you're talking about L1 and L2 applications. Now when it comes to L3 applications, and you're gonna understand what I'm talking about if you look at my other playlist on my YouTube that I'm actually doing right now, which is about the application security verification standard. When you're talking about L3 applications such as banking applications and applications with higher sensitive or highly sensitive information such as medical applications, then you want to go levels deep. But of course, when you're dealing with those sort of applications, your pay per hour is going to increase, or the time spent for or on the entire project or on the entire pen test is going to be increased. Let's actually see how we're running on time here, because this time is not counted in dollars, but this is actually free time that I'm investing. So 15 minutes. Did I submit this? I didn't. Let's see if we can do the next one in 5 to 7 minutes. Blind SQLi. Unlike the in-band where we can see the results, in blind SQLi we cannot see. You don't get any feedback to confirm whether or not your injected queries were in fact successful or not. This is because the error messages have been disabled, but injection still works. So even though the error messages have been disabled, in blind SQLi you need to know that the injections still work. So one example is authentication bypass. One of the most straightforward blind SQLi techniques is when bypassing authentication methods such as login forms. Alright, so in this instance we are interested in bypassing a login form and not necessarily retrieving data from the database. So login forms are connected to a database of users. Login forms that are connected to database are often developed in such a way that the web application isn't interested in the content of the username and password, but more whether this is really important, but more whether the two make a matching pair in the user's tables. Really important. Keep this in mind. In basic terms, the web application is asking the database, do you have a user with the username Bob and the password Bob123? And then the database replies with either yes or no. Depending on that answer dictates whether or not you're going to be able to proceed to whatever protected features are behind the login form. Now, taking the above information into account, it's unnecessary to enumerate valid username password when you're dealing with authentication bypass scenarios. Practical. Select all from users. Let's see. Do we need to actually reset this? No. You don't have access yet. Yeah, so I think we're here at level 2. We need to input something in here and in here to actually do the authentication bypass. Or we can see that select all from users where username and password is this. This is actually what happens right now. The username, so %username, %password are taken from the login form fields, the initial values, so in this case let's say admin, and they're actually inputted here. What we need to do is to actually break out of this quotation. To make this into a query that always returns true, which is exactly what we need in an authentication bypass scenario. Like I said, we're actually asking the database whether or not they have a username and the password with this combination, and and the database will reply with yes or no. If it replies with yes, you're going to be able to actually log in, so make sure to understand this. If it's going to reply with false or no, then you're not going to be able to proceed. So what we need from the application or from the database is a yes or no, not valid credentials. Thus, one example of to make this into a query that always returns as true, so that's what we're looking at, we're going to use the apostrophe and then or 1 equals 1, which is a statement in SQL that actually turns to true. So we're breaking out of the username field because select everything from users where username is nothing, and then this is going to return true, and everything that's afterwards, we're gonna finish the statement here with the semicolon and then minus, minus, or hyphen. Everything that's after that, the password does not actually matter because it's taken as a comment. And if we click on login, you bypass the login and can now move to the next level. Level 3, I believe this is the one that we need to import, right? Let's copy the one from here. And then just put it in here with 9581. Alright, task number 7 is done. Next, blind SQL Boolean based, time based, which is really important. So as you can see, they're focusing on blind because that's something that's most often encountered, because in many situations the developers have actually removed the errors from the application. So blind SQL Boolean based, time based, out of band SQL, so this is all in band SQL, and then remediation. So that's all for future videos.